Hey guys, it's TyKevin83. Today I'm going to show you a new technology for the web browser I'm calling RGB Scaler. It's a website and a set of code that you can follow to basically create a video player in the browser that is appropriate for use with pixel art and retro game footage. I'm going to walk you through first why this video player needed to be created, and then second, some of its use cases. So again, this is called RGB Scaler, and what it does is it's a viable method for playing back pixel art from retro game consoles, very often very small resolutions at much larger sizes in web browsers, so that you can use up your whole screen. Through storing lossless or very little loss footage from retro game consoles at small sizes, with full Chrome and before par correction, archives of game footage can be kept very small and still displayed their sharpest on the web. And now the reason this is necessary is because there's no CSS tag like image rendering for use with video on the web. There's only image rendering for the image element itself. So there's some examples here in the README of how to go about encoding videos in a way that works best with this scaling method. But now that I've gone through some of that, here's an example side by side here, just from still images of the sort of visual difference of scaling the way the browser typically does versus the way that the RGB scaler site does. And then some more explanations of the benefits and bandwidth savings. So over here, I've pulled up a video from the RGB Scaler site, but I've pulled it up on a demo site other than RGB Scaler that uses the normal method. The entire site here, just for this example, is just a video element and a style tag to set the video to the full height of the browser. So if we play back this video, you can see that it looks very blurry in parts. It's not too bad right there at the beginning, but then, okay, you can see there on the copyright footage, there are actually gray pixels around the corners of a lot of these O's, and they're completely invisible. They've been completely blurred into non-existence, and I'm not sure. I don't really like that. It doesn't preserve the appropriate pixel artness of the font, and it does some weird things to the shapes of the copyright logo. And then if we pull back to the Pokemon Gold version here, this isn't too bad. It kind of helps with some things like the background has some dithering effects that could be blurred, but it's not really blurring them in a way that helps like make use of the dithering effect. It's just blurring things a little bit in a way that's not really helpful to the art style. And then there's also pixels like you can see there's a remnant of a grayish pixel at the bottom of this N between the gold and the blue, but it's just this really weird shape and weird blurriness when styled like this. The browser is using bilinear upscaling by default, which is a pretty weak algorithm for scaling video up. Now, that being said, we have rgbscaler.com now. So rgbscaler.com is a couple different usage modes. There's an integer mode and a max mode. And the integer mode, what it does is it says, okay, we'll only scale this up as many times as is an exact multiple to make sure the edges are perfectly sharp, as absolutely sharp as they could ever be. And the max method says, hey, I'm okay with losing a little bit of sharpness as long as you use the entire available size of the window. So the max full screen, you can see here, it uses the full screen, and the max window uses the full available space of the window below the controls. And you can see if we play back the integer one a bit here, you can see, like I was saying, there's these very solid gray pixels in all the corners of these numbers. And if we play ahead more, it's difficult to be very precise with the player controls, but we can work on that too. So if we advance here to the Pokemon Gold version logo here, you can see the edges, like where the bottom of this N is, very tightly preserved. The gold version, actually, I love the way that the words gold version look with this kind of scaling compared to the blurred version. If we go back here, gold version looks exceptionally blurry, almost to the point of being a slightly more difficult to read than this gold version. If we go up to the max still though, now we're scaling at a non-integer multiple, and yet it still looks very, very sharp. And this is because if we take a screenshot just to do some pixel peeping and look at the edges here in a tool that scales in a way that's helpful for analysis like this. So we look super deep in and peep at the pixels. It's preserving the shapes of pixel elements. So even though, like right here on the boundary between this pixel that's gray and this lighter pixel that's a light blue, it's only blending 2 pixels right on the edge there. And you can see in the upper left corner here, it's got a pixel that's even closer to being the one in the upper left. So it's only blurring things right on the edge where a boundary happens between 2 different pixel colors. So that's very fun. That really, at least in my opinion, helps make the area average algorithm quite a bit more exact to the original art style. And if you can see again, if we zoom back out here to 100%, you can't see, you cannot see at all that it's doing this blurring on the edges of the pixels, because it's doing it only in that 1 pixel layer right on the edges. So if we do the same thing for the edges on let's see, if I go over here and pixel peep at the browser based one, you can see it's blurring so many layers of pixels around the same edges, and that's why it looks so much blurrier when upscaled this way. So you can see there's a very significant, and look also here at the shape of this pixel. It looks very rectangular and like wide, whereas if we go back, there's a square pixel here, 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 and here. So it's very strange what it's doing to the shapes of the pixels with the native browser video algorithm. So just going back to RGB Scaler. Now there's one other thing I wanted to show you guys. If we choose a file here and pull up this Atari file, there's a great extra feature here by doing the scaling at the last step where it's being displayed in the browser. We can do this thing called pixel aspect ratio correction at the final step. And so we put in the pixel aspect ratio. That means basically the dimensions of the pixels as they would have been displayed on a CRT. They would be about 1.86, or we could also put in display aspect ratio of 1.33. That's very similarly equivalent. We're just saying that the CRT is approximately a 4:3 display. So if we set that and then we hit play here, you can see the Atari footage is the appropriate aspect ratio, even though the source footage is not at all the right aspect ratio. It's much too tall. And by waiting to do this aspect ratio correction step to the browser here, at the final step of playback, we get much sharper lines, much sharper pixels. So I got to take care of Jerry here. He's begging for a walk. So thank you guys for watching this. I hope you guys can check out some of the example footage on rgbscaler.com. And if you guys have any of your own files, you can click choose file here and then click play, and it'll play them back with this area averaging filter. It's the same area averaging used by OBS. So if you use OBS for streaming pixel art games, it's the same concept. This just lets people play them back in the browser in a way that looks the absolute sharpest it can on their monitors. So thank you, and you guys have a great day.